Everyone, welcome back to Dev Parkour. In this video, we're actually going to do some coding. It's been a long time. Um, but in this video, I want to show you how you can get the actual name of the command that a .NET app was run with. Um, there are a lot of answers to this question online for Windows. The reason that they're Windows specific is they use WMI, the Windows Management Interface, I think is what it stands for. And that's great if you're running on Windows. But I'm not. I'm running on a Mac right now. I also do a lot of .NET on Linux. Um, and on both of those platforms, there's a very common paradigm where, uh, especially system level programs, will try to detect the command that was used to invoke them and behave differently depending on how it was invoked. This stems back all the way to kind of the original Unix days, where there were like very primitive versions of commands, like let's say ed, the line editor, where you couldn't even see anything. You couldn't see what you were editing. You edited a file basically by sending commands to it, and various programs built on top of that. Ed became EX, became eventually VI, became Vim, and so on and so forth. And some of those programs, some of the later versions, will actually detect if it's been invoked using an older version of the command. It's not as crazy as like Vim detecting that it was run as ed and emulating ed mode. Um, but some of the earlier versions of that, like EX, might detect that it was run as ed because there would just be a symlink from /bin/ed to /bin/ex, which was the actual executable. Now, in .NET, that's not a very common paradigm, but if you're writing a piece of code, .NET, some of the newer versions, is making strides to kind of compete with languages like Rust and Go, and some of the things that they're introducing, like single executable build, where you end up with just one executable at the end instead of a whole directory full of DLLs, or um, some of the other things that they're doing around platform specific builds, uh, kind of make it a contender for maybe not super systems level things, but sort of like service level sort of things. Um, maybe like daemons that you might be running on a Linux system. It's very practical for that. But you might want to do this paradigm where you're detecting what command was actually used to run your .NET executable, which might just live in, as a single executable. It could very well just live in /user/bin, and you might symlink to it from other places, and you might want to detect how it was being run. So I'm going to go through all of the examples that I could find online of detecting, and I'm going to put this in air quotes, how the program was invoked. Let's kind of start at the top. The first example is, as you might imagine, environment.command line. Okay, that sounds right. I mean, the command line is how we're running it. But let's see what we actually get. We'll do .NET run. Let's save this first. See what we get. The build, and it'll spit out. I'm naming this program "How was I run," and it prints the entire path all the way to a DLL. Now we know this is wrong right off the bat because you can't run a DLL directly, right? Even if I'm 90% sure that this won't work. If I try to run this directly, yeah, I can't run a DLL directly. It just doesn't work. You can't even do that in Windows. You have to run an executable, either a .exe on Windows or an actual ELF file on Linux, or I guess it's a Mach-E executable. Or that's not right. Mach? Mach-O executable on that? I don't know. It's been a while since I got down into those levels. Anyway, anything that ends in .dll is wrong. So moving on, let's try this one, which also looks promising. Environment.get command line args 0. Okay, it's a common pattern in C programs to grab argv and take the first element at index 0. That is traditionally in C programs the very first piece of the command that was used to run whatever program you're writing. And in C programs, the equivalent of this is absolutely the right answer to this question. You can just end this video right here, get command line args 0, that's the answer in C. However, let's see what it gives us in .NET. Do .NET run, it'll build, and it'll run it. We'll see what we get. Okay, same exact thing. Okay, so that's wrong. Now, while we're talking about wrong answers, let's go ahead and grab this, which, yes, this was actually an answer that I saw on the internet. Anything that's assembly.get executing assembly, just wrong right off the bat. We don't care about the executing assembly. We don't care about its location, because the use case that we're after right here is a symlink in a different part of the file system pointing to what might even be the executing assembly. But as we'll see with .NET Run, I guess we should save our file first, shouldn't we? All right, .NET Run, we get the exact same thing. Okay, so all of those are wrong. Now let's get a little bit closer. Well, I kind of gave away spoilers. This one, environment.processPath. This one is a little bit closer, and we'll see why in just a minute. So here we have how was I run without the DLL. Let me show you why this is a little bit closer. So I'm actually going to go over to the File Explorer over here, VS Code. We're going to dive into bin, into that directory. So here's the DLL that actually contains most of the code. It doesn't matter that we're not actually publishing it, because the single executable mode really only matters when you're publishing. It actually does demonstrate, since we're not bundling it all into a single executable, that everything I'm showing here in this video is actually a different thing. So this is the actual executable, the actual entry point on Mac. And there's a file with the exact same name. It's slightly different on Linux. That kind of wraps and runs the DLL. That is the actual .NET DLL. As of right now, this DLL is portable. I could take that DLL and bring it over to Windows, and it is just a .NET DLL. It could run just fine on the CLR. Obviously, I'd have to have some way to invoke it, right? Because as we mentioned, you can't run a DLL directly, but that DLL is completely portable. Now, when I publish it, it'll bundle this how was I run file and how was I run.dll all into one package called how was I run. And then everything that I'm showing you here, except for the very last one, which actually does work. We haven't gotten to that example yet, but all 4 of these plus one more that I'm about to show you will all print out the exact same thing, which is incorrect, which is why I haven't actually created a symlink. Well, actually I have. I'll show you what that is in just a minute. But we haven't even run it by using this symlink because we haven't gotten the right answer until right now. So let's show the last example, which is get current process. This looks promising. Main module. Okay. .file name. Okay. So now we're getting the main module of the program, but we're getting its file name. We're not getting the file name that was used to invoke it. So as you'll be able to see when I do .NET run, it will show bin debug net7 how was I run. Now, this is correct because .NET Run is actually a separate program, and what it does, it doesn't exec the program that I've built. It runs it as a child process, and the thing that it runs as a child process is this path right here. Okay, so now let's test what we actually care about. So if I do ls-l run it, we can see that it's pointing to bin debug net7 / how was I run. So if I run /run it, it runs the command, it runs the program, but you can see that the output is no different from when I ran it using .NET Run. In fact, if I run this command here, exactly the same. So running .NET Run, running it through a symlink, running it via the full path, doesn't matter. I'll get the same output. Now, the thing that does work is kind of a mess. This will only work on Linux, macOS, and it might work on Android because it's Linux based. But I don't know that you have access to the ps command. But basically what we're doing is running ps. So if I run ps-p with some process ID, I don't have a process ID right now, and then -o command gives us the initial command. It gives us basically argv0 equals removes the header line. So typically when you run ps, you get headers and then you get a list of processes. Adding that equals at the end disables that header line. So basically what we're doing is getting us the information for a specific process, and the information that we're getting is the name of the command that was used to run that process. And some other fanciness to basically just write it to a string so you can save it, and then console.writeLine it. So let's save this, and let's start with .NET Run. Did I actually save it? I didn't save it. There we go. Let's save it. Let's try this again. .NET Run. Okay, that makes sense because we know .NET Run runs this command. That is legitimate. That is the output we're expecting. Now, if I run it from the symlink, there we go. We actually get the right thing. Now, let's add some arguments. Let's just say we ran it with help. One thing to note is that this command from ps, I misspoke earlier. It's not just argv0, it's all of argv. It's the entire command line that was used to run the command. So if you really only want that first part, you do need to split it on strings and grab the first piece. Not a big deal. As far as I can tell, I haven't found a way to just get argv0. I would hope that you're not putting spaces in the names of your binaries. But if there is a space in the name of your binary and you try to split on spaces, obviously you're going to lose pieces of it. If you know the ps command a lot better than I do, please let me know in the comments. But for now, that's all I got for you. This is the code that I'm going to use to do this for my Linux.NET executables. Like I said, there are plenty of examples for Windows. All the Stack Overflow answers that talk about Windows are, well, I can't say all of them are right, but all the ones that I found, I assume are right. They all use WMI. But go ahead and check them out. If you like this video, go ahead and hit the thumbs up button, subscribe, and let me know your thoughts in the comments. Thanks for watching. See you in the next one.